Dear students, let us see what is there in this question. Seems horrible, I will say. There is a proposal to power a space satellite X as it orbits the Earth. In this model, X is connected by an electronically conducting cable to another smaller satellite Y. So there is another satellite which is Y, there is another satellite which is X, the two satellites, and Y is closer to the Earth. Okay, the satellite Y orbits closer to the center of the Earth than X outline Y. What is that? Okay, I think there will be a connecting question. Outline why, because this is generally there is a problem with the paper two questions in regards to the statements. Okay, so the cable acts as a spring. The satellite Y has a mass of this. Under certain circumstances, the satellite Y will perform simple harmonic motion of the time period 5.2. So even the time period is given. So it is already given that it is performing simple harmonic motion, and the time period is 5.2. Satellite X orbits 6,600 kilometer from the center of the Earth. Okay, mass of the Earth is this. Show that the orbital speed of X is about 8 kilometer per second. So the total distance is given as 6,600 kilometer. You have to find the orbital speed. Okay, dear students. So as per the orbital speed is concerned, I remember the formula is this, and I think that will be given in the data booklet, or you can even derive it from the circular motion, like the centripetal force, which is mv square by r, that will be equated with the gravitational attractive force, and thereby you can just find the formula, and that will be this. So v naught is equal to square root of gm by gm by r. So the value of g is 6.67, 10 raised to power minus 11. Mass of the earth is 6 into 10 to the power 24 kgs, divided by the radius, which is 6,600 kilometers. So we have to convert it into meter, because whenever we are taking square root and all that, like, it is very very important that you convert it into meter, otherwise your answer will definitely be wrong. So we have to square root it. So I'm not using my calculator to calculate all of these values. We will just see the mark scheme, and we will take the numeric value from that. So this is the orbital velocity. So A, and we're going for the mark scheme, and A is 7,800 meter per second. You can see this is G, this is mass, and this is the radius that they have taken. So the answer is 7,800 meter per second. It's huge, like 7.8 kilometer per second. But yes, there is no surprise. This is what is generally the velocity of the satellites, isn't it? Okay, anyways, let us move to next. We have to remember it, 7,800 meter per second. Just write it here. Yeah, so the next question is B1. Uh, yeah, the orbital times for X and Y are different. Okay, now is the time for that statement which earlier was not making any sense. So outline Y. Satellite Y orbits closer to the center of the Earth than the satellite X. Outline Y, the orbital time for X and Y are different. So my dear students, as we can see that the velocity is given by gm divided by r. Obviously time we can find 2 pi r divided by the orbital velocity. That will come out to be equal to square root of gm, and r raised to power, like half will be here and 1 will be there. So I think you would be having this formula in your data booklet also, and you must be remembering it. Yeah. So this is the formula for the time period of the rotation of the satellite around the Earth. Obviously, this is dependent on the radius of the circle. It is dependent on the distance of the satellite from the center of the Earth. So it is different for Y, it is different for X. For X, it is more. And for Y is lesser. So for Y, it means that Y will be taking lesser time to cover the one rotation, and X will be taking more time. So the time for X will be more than time for Y. So they will not be able to move parallel to each other, or like they will not be able to move at near to each other, definitely there will be a relative velocity, so they are going to separate after some time. So what is the next question? So the orbital time for x and y are different, so I have given you the reason for that. And b2 is why the satellite y requires a propulsion system. Obviously it will be requiring a propulsion system. Why? Because x is moving at a different angular velocity. Yes, now let us find the angular velocity of x and angular velocity of y. So you can just say that it is 2 pi by t, 2 pi by t, and 2 pi by t, because the time period is different for x and y, the angular velocity is different. So obviously one is going like this, so other would be moving at a faster speed, so y can move at a faster speed. Sorry, y, for y the time period is lesser. Okay, just a moment, let me make sure this thing, because the radius is more for x, the time period will be more for x. Yeah, there's no doubt about that. And so the time period will be more for x, so y is moving faster, it means. Okay, so there will be the propulsion system, but this propulsion system will be working in opposite way. Okay, like to reduce the velocity, so there will be rockets which would be firing in the opposite direction to reduce the velocity of the satellite y. Okay, fine. Even then, it is defined. So now we have completed the question A and we have completed question B1 and B2. Let us go for the mark scheme and see what are their answers, what they want to say. So first of all, the velocity is 7,800 meter. Y has smaller orbit. So the speed is greater. So time period is lesser. Yes, so it will be moving faster. So to stop Y from getting ahead, we would be needing a propulsion system that will be firing against it. So they might have explained it. Otherwise, this will add tension to the cable and damage the satellite, obviously, to remain stationary with respect to S. Yeah. So X is moving at a lower speed, but Y is moving at a faster speed. So there will be distance. So what we will do, we will use the propulsion system that will be working against it. So to keep the angular velocity of X and Y intact or same, equal, that is why. Let us go for the question number C now. The cable between the satellites cuts the magnetic field lines of the earth. Oh, so now we are moving to topic 11. Earlier we were in topic 10, now it is topic 11. So this wire is now cutting the magnetic field. They have shown the diagram so that there is no confusion, like how is it cutting the magnetic field. Anyways, it is cutting the magnetic field. So explain why the satellite X becomes positively charged. Okay, fine. So the X is becoming positively charged. So there is this wire. This is Y. This is X. Magnetic field is clearly in the upward direction. And the velocity is into the page. So I can just draw it like this. So the velocity is into the page. We have to find like which end is becoming positive and which end is becoming negative. So my dear students, this question is from topic 11.1. And in while we were doing the paper 1 questions for 11.1, I have completely explained like what directional rules that we can use to find the direction of the EMF or the induced current. So you might be knowing this, that I am using right hand palm rule type 3 here. Okay. And in this, we just keep our fingers in the direction of the magnetic field, and thumb is towards the direction of the velocity of conductor. And so the palm will start pointing towards the direction of the induced current, or the direction in which the positive charges would be experiencing force. So this is the conductor X to Y. Yeah. So the magnetic field is upward. So my fingers are upward. and the velocity is into the page, so I can keep my hand like this. Okay, so magnetic field is upward, velocity is like this, so it would be going towards this. So it means that x is going to become positively charged and y is going to become negatively charged. So they are saying like explain why. So we can explain it that with the help of you can just point out any of the rules, like you can call it like the Fleming's hand, right hand or left hand rule. I don't remember that because I don't use them. Okay, so you can say that we are using Fleming's left hand rule for the inductions or the right hand rule for the induction. Yeah, right hand rule. So the force will be experienced by the positive charge towards the right hand side owing to the magnetic directional rules. And so X is going to become positively charged and Y will be negatively charged. So this is done now. Okay, what next now? Explain why the X is positively charged. This is answered. D. State satellite X must release ions into the space between the satellites. So obviously it is getting positively charged, so it should release the ions in the space. Explain why the current in the cable will become zero unless there is a method to transfer charge from X to Y. Obviously this is an EMF is induced, like this X is becoming positively charged, Y is becoming negatively charged. So this thing is actually acting like a battery now. So this end is X, this end is Y. So until and unless we create a wire which goes like this, the circuit is not complete. So until the circuit is not complete, the induced current will not be there. Okay, but what will be there? You see, the charges will be moving for some moment, for some time, for some duration. The charges will be moving, and after that this end will become positively charged and the other end will become negatively charged, thereby creating an electric field here. So there is a theory there to supplement our answer. And what is that? Let us say there is a positive charge here and it is being acted upon by a magnetic force. Still the magnetic force is acting towards right hand side direction, so because all of your rule is still valid. But why now the charges have stopped moving? Why? Because this side is now sufficiently positively charged. It is able to create a repulsive force on the other positive charge which wants to accumulate there. So there will be a repulsive force. So this force will be getting cancelled out. So there will be a counter force F, you can just say E. So that will be QE. And the magnetic force will be QVB. So these two forces will be equated with each other now. And so the positive charge is not feeling any force now. That is why the charge will stop moving. So there will be no current anymore. So until and unless you complete the circuit and all this positive charge starts moving through and it starts going towards the negative side and canceling the positive and the negative charges together, the electric field is not going to reduce, so there will be no induced current. Well, my dear students, I'm just trying to go as deep as possible. I'm trying to make my explanation deeper. So it might be that you might be getting confused. If you're getting confused, please do let me know in the comment section so that in the next upcoming videos I will not be doing that. I will be more careful. But I think everything should be clear to you now, isn't it? Okay, so this is done now. So that is why there will be no current and the wire has to be connected. The magnetic field strength of the earth is this. The cable of 15 kilometer in length, calculate the EMF induced. Okay, so EMF will be BLV and the magnetic field strength is already given, which is 31 into 10 to the minus 6. Length is 15 kilometers, so it is 15,000. And the velocity with which it would be moving. Okay. Um, See, although we cannot say that it is a straight wire and the wire is moving in exactly say in exactly straight manner, it is not like that because it is actually moving in a circular manner. But because that formula is not in our syllabus, so I am sure that you would be required to use the same formula, which is BLV. So V can be the velocity of the satellites, and we can just assume that both of the satellites are moving with the same velocity, and there is no relative velocity because it is in the circular motion. No, so X will definitely be having more velocity, Y will be having lesser velocity, and there has to be a different formula for instead of BLV. But that formula is not in your syllabus. So that is why we would be using BLV. So this, and the velocity of the satellite was, I don't remember, it was 7,800 something, 7,800 meter. So it will be 7,800 meter per second. So this is how we are going to find the electric field, and let us verify. Yes, we are using the formula BLV only because we can neglect the rotary part of the wire because the length is very small. BLV, and so the answer is 3600. So the answer will be 3600 volt. Fine, this is how we do this. Let us now see. Okay, so E is done, and we are now moving to the point F. So F1. Estimate the value of k in the following expression. So t is equal to 2 pi root of m by k. So they are clearly referring to the simple harmonic motion now. And I think time period was given, and the mass of the satellite was also given. So we have to see where it was given. Yeah, here. So the mass is given as 3.5 into 100. So you can just call it 350, and the time period is taken as 5.2 second. So t is equal to 2 pi root of m by k, and by applying this formula we can find the value of k. Let's go to the mark scheme and see what are they doing. Yes, they are doing the same thing. So they have first just isolated the value of k from this expression. They created a new expression. They substituted the values here, 350 kgs, and the time taken is 5.2 clearly. So we would be getting the same answer, and that is 510 Newton per meter. And so now we are going for the last question. F2. Describe the energy changes in the satellite Y cable system during one cycle of the oscillation. So in the system, you are just considering only the satellite Y and the cable. We are not considering the satellite X. So satellite X will be just supposed to be like the part of the surrounding. We are just able to like, we would be concentrating on the spring and the mass, which is the satellite Y. So obviously, what kind of energy transaction is taking place here? So the kinetic energy of the satellite, it is moving like this. So that is being stored as the potential energy in the spring. Clearly, elastic potential energy of the wire is being converted into kinetic energy of the satellite, and continuously it is moving like this, and also it is moving in a circular fashion. So it's moving like this, like this. So the satellite is going like this, X. So we can just write that the elastic potential energy is converted into kinetic energy. Yeah, EP in the cable system transfers to the EK of Y. Clear? Back again twice in each cycle. Yeah, because in one oscillation, the kinetic energy becomes maximum twice. So the potential energy is also becoming maximum twice. So you can also write that. So this is how we do this question. It was a very long question, no doubt about that. And I think like it's more of a comprehensive question. So you have to first understand what they want to say. It's actually not a question, it's basically a case study kind of thing, isn't it? So you have to first study the statements, you have to see all the things that are given to you, you have to see all the questions, and the data book is there, so you can just find the formulas, and if you remember them, you just plug in the values and get the answer. So you must know how to analyze the questions properly. What is the thing that they are actually finding? So this is really a practical question. I really love this question, isn't it? Okay, so my dear student, this is Professor Varun. It has already taken 20 minutes for us to solve this question, isn't it? Thanks for joining the YouTube channel. Please tell your friends, other students to subscribe to the YouTube channel, also to join the YouTube channel and access all the paper 2 questions. All the best. Bye.